Measures of Science. Make sure you have your notebook available and you'll take these notes on your next available page in your notebook. In science, we use the metric system. The metric system is the standard of measurement that all scientists use. It's very easy to convert between units because all the units of the different sizes are related by powers of 10. The base quantities that we end up using are length, time, and mass. And we use these three as base quantities because they are things that can be measured very easily. We can measure length with a meter stick or a kilometer or something like that. We can measure time with a clock, seconds, and we can measure mass with grams or kilograms. All other quantities can be described using a combination of these three, which is why these are the base quantities. These are the simplest ones that we have. And the units that we use for these are called base units. Draw a table like this in your notebook. Make 3 columns. Title the first column base quantity, the second column base unit, and the third column symbol. The first base quantity we're going to look at is length. So write length in the base quantity column. The base unit for length is the meter. And the symbol for meter is a lowercase m. The second base quantity is time. The base unit for time is the second. And the symbol for the second is a lowercase s. And the third base quantity is mass. The base unit for mass is the kilogram. And the symbol for that is lowercase k, lowercase g. So mass, time, and length are all of the base units, and all other units are going to be derived. Derived means that there is a combination of the base units. And the easiest example that you're probably familiar with is speed. And speed is a combination of length or distance and time. So if we were looking at the units for speed, speed can be measured in meters per second. And if you think about that, it's meters divided by seconds. So we're going to take meters, which is length, and divide it by time. And that would give us m over s, which would give us meters per second. Visualizing data is a very important skill you'll need in physics class. So data is any sort of information that you can collect, things like measurements, measuring the length of something, the distance an object has traveled, counting how long it took for a ball to drop, so that would be time. Any information that you collect is counted as data. Organizing that data into graphs and tables is going to give you more information. So just like the table that you just drew with the base quantity, etc., tables are going to help you organize that information, and graphs are going to help you derive some patterns, hopefully, from that information. So before we go on to the graphs, let's just review for experimental purposes. So we have 2 different variables that we deal with in an experiment. The first variable is the variable that the experimenter changes. Which variable does the experimenter change? If you remember correctly, the variable that the experimenter changes is the independent variable. And the variables that change as a result of that change, remember, those are the dependent variables, or a dependent variable. We sometimes call those the resulting variable because they are the result of the independent or the changed variable. Here is an example of a graph that you could probably see pretty easily. Okay, it's a graph of distance and time. Time is the independent variable, distance is the dependent variable. So if you look at the graph, this is telling us that as time is increasing, or going this way, that the distance traveled is increasing until we reach this 10-meter mark. At the 10-meter mark, you can see that the slope, or the line, is horizontal, which means that the person or whatever object was moving is standing still. But you see that time is still moving because it's still going this way. So this graph is actually showing us that between seconds 1 to 6, the object or the person is moving, and between 6 and 11, the person is not moving at all, or the object is not moving at all. It's staying in the same place, but time is still continuing. Then you can see that as we continue with the time, that the slope is going down, or that the graph is going down. So that means that the distance, the person walked 10 meters away, and now they're returning to the point of origin, or where they started. There are two types of relationships we're going to look at. The first is a linear relationship, and all a linear relationship is when a straight line can be drawn through all data points. So after you've collected data, you've graphed the data, and if you can make a straight line, or a relatively straight line, through all of the data points, then that would be a linear relationship. Linear relationships have a very standard equation that goes with them. The equation is y equals mx plus b. If you recall from your math class, the m is equal to the slope, and the b equals the y-intercept. The slope is actually a ratio of the vertical change, which is on the y-axis, to the horizontal change, which is on the x-axis. And we can use the equation for slope, which you should have learned in your math class, or you've already learned, or you may learn in your math class, is going to be the rise over the run. So it would say that we are rising over here, and then we are running. Or this is the delta y, which is the change in y. Delta equals change in, over the change in x, which would be here. So delta y over delta x gives us the slope. The second type of relationship that we can look at are the nonlinear relationships. And the nonlinear relationships are just when a straight line can't be drawn through all the data points. So you've collected some data, you've drawn out the data onto a graph, and you realize that there is no way that there's just a straight line. Most of the times, if you cannot draw a straight line, you might see a curve that is there. So if you take a look at this graph of position versus time, you can see that this is definitely curving up to the right. Many times when the graph turns out to be a curve, it could be a parabola. And a parabola are where the variables are related quadratically. And you're probably familiar with the quadratic formula from your math class. The quadratic formula is y equals ax squared plus bx plus c. This equation is telling you that a parabolic relationship exists when one variable depends on the square of another. So you can see that there's a square in that equation. Another type of relationship that is nonlinear as opposed to the quadratic is an inverse relationship. And what happens in an inverse relationship is that one variable increases and the other is decreased. Many times when we have an inverse relationship, the graph can end up being a hyperbola. You may have seen those before in your math class. The equation that will form a hyperbola is y equal a over x, and a is a constant in that situation. So nonlinear relationships can create two types of graphs. You can have the graph of a quadratic relationship, which is going to end up being a curve, or a parabolic curve, and the second type of graph that you can have is an inverse relationship between x and y, and that would create a hyperbolic curve. Congrats, you're done. Have a nice weekend.